Hello everyone, I am Mukut Chaudhary and my ID is 211202003. Today is my presentation topic is Fcfs and SGF in operating system. We can go the next slide. So Fcfs and SGF is the part of single processor scheduling algorithms. There are mainly six types of process scheduling and algorithm. First is fast come fast serve and shorted job fast, which can call SGF, shorted remaining time and priority scheduling, round robin scheduling, and multi-level queue. Now I can go to the next slide, which is said on FCS. FCFS fast come fast serve, or FCFS. What is this? The fast come fast serve scheduling algorithm operates in a way of non-primitive way. The non-primitive way means that if a process is started execution, then the operating system must complete its process. Until the burst time of process is zero, the new or next process doesn't start its execution. So the main theme of fast come fast serve is which process will come first. That depends. That will come that will complete at first, and the next will start after complete this first or job. Which process will come first? That depends on the its arrival time. Example of FCS and its process. There are given an example of process FCFS. There are the five process and their burst time and their arrival time. Now we can see how can we solve this problem. So there we can see that there are five process and they are given are their arrival time. We'll take the process by their arrival time. So at first, which process will come? At first, P4 will become because the arrival time of P4 is 0. We can see that there are come P4. So P4 when start P4 will start 0, and when stop its first time is 3, then it will be stopped at 3. So it's start from 0 and it stop the ending point is 4. P4 is 3. Then now we can see that P3, the arrival time of P3 is 1. So there are not any process that its arrival time is 1. So we can say that after P4, P3 will be come to complete its job. So there we can see that the P4 is come at first, and secondly P3 is come. So P4 was 0 and P3 and the ending point of P4 is 3, which is also can be said that the starting point of P3, and P3 will be end at it after complete this. So the burst time is 8, so P3 will be completed 11. After P3 we can see that there are P1 which arrival time is P2. After P3 the P1 will become and complete this time. So after P3 P1 is come, and we can see that the starting point is P1 is 11 and the ending point will be 17 because the burst time of P1 is 6. After P1, which will become P5 will become, because P5 will become because the arrival time of P5 is 4. So P5 the starting point of P5 will be 17 because the P1 completes its jobs is 17, or the ending point of P1 was 17, and the starting point of P5 will be 17, and the ending point of P5 will be 21 because the burst time of P5 is 4. And at last the arrival time of P2 is 5, and after P5, P2 will become and completes its job. So we, we can see that the starting point of P2 is 21 and its burst time is 2. We can see that the complete time or the ending point of P2 is 23. So that's the solution of the FCFS problem. So we can solve the problem in this way. Now we can go the SGF, which is called shortest job fast. So which is shortest job fast? Shortest job fast or SGF is an algorithm in which the process having the smallest execution time is chosen for the next execution. The scheduling method can be primitive or non-primitive. It significantly reduces the average waiting time for other process, average waiting and execution. We can see a problem of SGF and example that we can solve. So there are any example of SGF which is non-primitive because arrival time is not given there. So so now we'll solve the non-primitive SGF solution and its process. We can so how can we solve a SGF problem? So there are the process and burst time of SGF example. So there we can see that there are 5 process and there are also given their burst time. At first, which process will become? We can see that the shortest burst time or lowest burst time is P5. So we can show that the shortest job fast. So shortest job fast in this table is P5. So at first P5 will become, and the start point will P5 was 0 because there are not any arrival time. So 0 from 0 P5 will be start and the ending point will be 3. After P5 we can search which is the lowest burst time. So we can see that P3 is the lowest burst time. So after P5 P3 will become to and completes this process. There P3 will become and the starting point is P3 will be 3, which is the ending point of P5, and after completes its jobs it will be end at 9. P3 is complete. After P3, which process will become? There are three processes remaining: P4, P2, and P1. We can see that from this process, P2 is slower or slowest in the remaining processes. So we can see that P2 will become because the burst time of P2 is lower than P1 and P4. Which is the start point of P2? The ending point of P3 is the start point of P2. And which will be the ending point of P2? Its burst time is 8. So after completes its jobs, it will be int. So when it will be just 9 plus 8, then it will be 17. So after 17, it will be completes its job and the 3 process already completes its job. So which process are remaining? P4, we can see that P4 and P1 are remaining and they are waiting for complete their jobs. So after P2, there we can see that P4 and P1 is remaining. So we have to search which is the lowest of their as their burst time. We can see that P4 burst time is 10 and P1 burst time is 9. So we can see the burst time of P1 is lowest. So after P2, P1 will become and it will be started its completes to its job or yeah. So the start point of P1 will be 17 because the end point of P2 is 17 and the start point of P1 is 17. And when it will complete its job, then it will be 26, এবং it will be its complete point or end point because its burst time is 19. After P1, there are remaining only one process, and it will come there and do its job. So we can see that after P1, P4 is come and started to doing its job. So the start point of P4 will be 26, and 26 plus 10, 36, and the 36 is the end point of P4. And we can see that all the process are already complete and there are not remaining any process. So the SJF problem is solved. Uh, the non-primitive uh, the non-primitive SJF process is solved, but if the process will be primitive, there are given will be arrival time, and we have to solve the another way. So thank you everyone for giving me the giving chance the presentation, and thank you sir